We all grew up learning Newton's laws of gravity. Drop a pen and it falls. The earth orbits the sun because of a gravitational pull. But there's a problem. Newton's gravity assumes an invisible force acting at a distance. How does the sun pull on the earth, and why does Mercury's orbit not match Newton's predictions? To answer this, Einstein gave us a completely different picture. Gravity isn't a force, it's the curvature of space-time. So if gravity isn't really a force, then what is it? Let's break it down step by step. Imagine you are in a spaceship, deeper in space, away from all planets and stars. You feel weightless. But what if the spaceship starts accelerating? Suddenly, you feel a force pushing you back, like gravity. This is the key idea of Einstein's equivalence principle. Being in a gravitational field is the same as being in an accelerating frame. This is where Newton's force idea starts to break down. If gravity and acceleration are the same thing, then maybe gravity isn't a force at all. So if gravity isn't a force, why do objects still fall? The answer, they are simply following the straightest possible path, called a geodesic, in a curved space-time. This is geodesic equation, and this is what the terms mean. In flat space, these extra terms disappear and objects move in straight lines. But when space-time is curved, these terms force objects to follow curved paths. Einstein's theory says that space-time is curved, but in a small enough region, we can still use Newtonian physics. This is called a local inertial frame, a small region where the effect of curvatures are negligible. This explains why for small masses and weak gravity, Newton's laws work perfectly fine. You don't need general relativity to describe a falling pen, but you need it to understand black holes or GPS satellites. So when do we use Newton and when do we use Einstein? Newton is still useful for most everyday physics, planets, rockets, even engineering. But when gravity becomes extreme, space-time curvature takes over and we must use general relativity. Newton's laws are like a zoomed-in view, useful for many things but not the full picture. Einstein's theory is a bigger picture, showing us the true nature of gravity, space-time, and the universe.